Hello, everybody. Thank you for joining today's webinar. Today, we are talking about what are dev containers and how to actually use them. My name is Daniel. I'm your expert for today's webinar, and let's continue. What will we cover with this webinar today? We are talking about what are the dev containers, what problems they can solve, common use cases, and how to actually use them. I will get into a little bit of detail about that, and we get them set up for you. And at the end, we will have a little troubleshooting session. What are dev containers? The standard definition for it is dev containers are containerized development environments configured via the dev container JSON file. So let's have a look at it, what it actually does. We have our local operating system and we have the container. We are basically separating the complete workspace that we're working on. We are just getting the visual feedback of the environment that we're working on. In this case, we are using VS Code. The VS Code visualized is on your local machine, and the VS Code server runs in a Docker environment. This way, we're going to have a complete separation of concerns, which I will cross over later on in the webinar for today. What are dev containers? The core files are basically separated into two files that we need to cover. The basic one is the dev container JSON, which is in the black window on the left side. And optionally, we have a Docker file, which you've probably used before if you are used to using Docker. I will go over the different aspects of these files once we are in the later part of the webinar. Just for your for a little visualization, we have those pictures right up here. Why should we use dev containers? Well, I've probably heard the term, it works on my machine so many times in my career. That's one thing that it fixes. It fixes the inconsistent environments. Sometimes when you are developing software or you are testing software, you have the problem that each and every single person has a different machine. For example, someone is using Windows 10, the next person Windows 11. Sometimes people are using Linux distributions. Sometimes people are using Mac. And with that approach, with the dev containers, we get rid of this problem completely because everyone is using the same Dockerized environment. It's great for using in distributed teams. People don't have to be in the same location. People basically don't even need to have the same setup because everything is running inside of Docker in a structurized way that is repeatable and reproducible. Instead of you just writing up some manuals on how to set up your environment, just use it. Right? So why use dev containers? We have some of the key benefits written down here. We have the environment isolation, so it does not mess with your operating system that you're currently running, right? You have the reproducibility. Everyone has the same environment. You get faster onboarding because you just have to let it set up for you automatically. You don't have to do it manually. Cross-platform consistency, as I told you before, we can work with Windows, we can work with Linux, we can work with macOS. Everything is possible if you are using dev containers instead of having everyone set up their machine manually, right? So there's a bit of a visualization. We are in the current world on the left, right? We have the local host where everything is set up on your local machine. You have your IDE running, your SDKs, your server, source code, the package managers, everything is installed on your local machine. But that's not good because sometimes your SDKs can change, your IDEs can change, and from person to person, it's always a different setup. That's why we want to switch over to the new world. We only use Docker and a remote capable IDE, for example, VS Code, on our local host. And everything else is set up in the dev container itself. The dev container provides you with the SDKs, with the servers and the package managers. And inside of the dev container, we have the volume mounts, which basically give you a little abstraction layer from the different SDKs and whatnot. So you have separation of concerns. So not everything is trapped in one place, basically. I will go over that later on. So what can what can dev containers do? Streamline development workflows, since everyone is using the same machines. Reduce setup friction, because you just have to run the setup and it does everything for you. Improve team productivity, because the earlier you can start, the more productive you can become. When are they used? Some of the common use cases where you have small polyglot projects where different environments are used. You know, as I said, Windows, Mac, Linux, you name it. Legacy code bases with outdated tool chains. That's a huge thing that I've experienced myself. Outdated tool chains. Speaking of React, for example, we had the situation where every update broke something. You know, it worked on their machine, then another person tried to download the repository, tried to run it on their machine, but once they ran their node package manager and everything was up to date, it did not work anymore because it used the outdated tool chains. So that's one thing it could get rid of. Another thing is the streamlined open source contributions. If you're into the open source community, sometimes you want to contribute yourself. And if you don't have the option to run the open source software, for example, what I have done in the past, contributed for the robot framework, right? When using the dev containers, you get the environment set up for you, and you can contribute way easier, right? So that's a huge plus. If you can just run it, do your stuff, upload it, and you're done with it. A nice list of what is it called? Curated dev containers. A colleague of mine will provide you with the link, or you can see it on the screen. It's called Awesome Dev Containers, where they have a curated list from different programming languages where you can check out some of the stuff that people have done for you, so you don't have to do it yourself, in different programming languages, also sorted by different concerns. Just check it out. It's awesome. Right. Dev containers sound great, but how do I actually start using them? You need some prerequisites. You need to have Docker installed, and you need something like VS Code that is capable of using remote connections. And you should also use the containers extension of the VS Code marketplace, right? So 3 things are the first stuff that you have to do. You have to create a .dev container folder inside of your repository. You have to define a base image, and then open the project in the container, because just having those files reside inside of your repository is not enough. You actually have to open the project inside the container. This is a basic dev container JSON file. I will just gloss over the different aspects of it. First, we have the image on top, where it says where the base image gets pulled from. In this case, it's from Microsoft / dev containers, JavaScript -node, and in the back you can see the version of it. It's using version 1.80 in Bullseye Debian as a base image. Inside of the features, you can provide it with multiple entries. And in this case, we want Docker in Docker. What that does, it basically gives you the option to use Docker inside of your dev container, which is very handy if you are having stuff running inside of Docker when using the dev container itself, because it's running Docker itself. Right. Post create command. What's that doing? That's a command that always runs once the container is started. In this case, it's running npm install. npm install, for those that don't know, npm node package manager install. -G globally installs the DevContainers CLI for you, so you can run it inside of the DevContainer. Inside of the customizations part, we have the VS Code section, and inside that section, we have the extensions section. This is a list of extensions that get automatically installed inside of VS Code once you run the dev container. So you don't have to do that yourself. It gets done automatically for you. Right, so that's one thing we glossed over, what it could look like. We come to the troubleshooting section now. I provided you with a list of 3 common issues that you can encounter with dev containers and how to actually fix them. For example, what I've encountered, we have a volume-mounted workspace, but it is very slow, causing long install times or build times. What you have to do, you have to keep the heavy build steps, like for example npm install, pip install, you name it, everything regarding package managing inside of a Docker file instead of the dev container file. That way you offload it to a later stage where it could use the full capabilities of the Docker itself, right? So instead of running it on your local host, run it inside of the container so it does not block your host file system. If you're using Windows, use VSL2 or use the delegated or cached mount options to reduce the sync overhead. That's something very special to Windows. If you are into Windows and using WSL, too, just give it a little checkout on the Git repository of the dev containers themselves. Microsoft provided one themselves. The second issue, after updating the dev container JSON or your Docker file, VS Code may continue using an old image or caches it. I've had that situation so many times, and let me tell you, it's a pain in the butt. What you have to do, you should have to trigger a full rebuild via the remote containers. Rebuilding the complete container from the VS Code command palette. I'm not sure which shortcut it was. I think it was Control-Shift-K to get the command palette. And inside there, you can trigger the full rebuild of your dev container instead of just having it run again and again, because then it's not going to update. What you can also do is use a version tag on your base image or increment a dummy build argument. For example, arg cache break equals 1. So it does not use the cached Docker image and instead downloads the fresh one. Issue number 3, files created inside the container end up owned by root or a different user ID on the host, leading to permission denied when editing or running scripts. That's a huge bummer. I had that so many times. I give you 3 different options what you can do to prevent that. Inside of your Docker file, match the container user ID and the group user ID to the host user. For example, what I provided you here, arg user ID, arg group ID, and basically run the script as I provided you in the screenshots, and you're golden. What you can also do inside the dev container JSON, you can pass your host IDs. For example, basically the same, build args, and inside of that, you provide the user ID and the group ID, so it matches with your local user ID and group ID also. What you can also do, use VS Code setting, remote user equals VS Code. That way, it sets the user in itself to VS Code and basically adjusts the user rights to this specific user. That way, there is no hiccups and permission denied gets eliminated because everything syncs up automatically for you. In summary, dev containers are a Docker-based configuration-defined development environment that ensures isolated, reproducible setups directly from your editor. They can help to streamline your development workflows, reduce setup friction, improve team productivity. All the stuff that you want and need at the end of the day if you have teams with different setups that would normally have to do it manually. Commonly used to provide a ready-to-use, consistent environment for onboarding new developers, as I told you before. Ensure identical dependencies, configurations across different host operating systems, right? Maintain polyglot or legacy projects to isolate complex tool chains and avoid host conflicts, what I also told you about before. Setting them up is as easy as those 3 steps. Create your dev container folder, define the base image inside the devcontainer.json file, and open the project inside your container, and you are golden. You're ready to go. Do you have any questions so far? I think we have 1 or 2 minutes left, so you can ask questions if you have anything in particular that you want to ask. Don't be shy. You can ask questions as much as you like. All right, since there were no questions, then I think we are at the end of our webinar. Our current offerings from Go Bigger. If you haven't done so before, please give us a follow on LinkedIn. You find us under Go Bigger GmbH on LinkedIn. You can check out our courses and workshops that we can provide for you in terms of regular testing, in terms of ISTQB, and also we provide a robot framework workshop. Check it out on go-bigger.de/shop. I think my colleague provides you with the link for that. And if you are into that stuff that we provide you, maybe subscribe to our monthly newsletter. It's called Grow Bigger, and it's just 1 email per month, so we don't spam you. Don't expect us to send you a mail every day. We show you all the different stuff that happens in the testing environment and areas, all the new stuff that you may know or may not know. So stay tuned for that. And regarding this, we are done with the webinar for this day. Thank you very much for joining us and have a nice day.